Now we have one type of logarithm left that we haven't gone through. I'm just giving you a quick crash course on this here. There's a base that we're going to use called E. It's a natural growth factor. It's all over in nature. I showed people where it came from. E, and we see right here, slide this up. In blue, there's an e to the x, and it's the second function of this button ln. Now I'll talk about that in 1 second. It's second e, and we'll just see what it is. E to the first is just e. So it's about equal to 2.718 and so on. You use this whenever you see continuous in the question. You have like a yearly interest rate, but it's compounding continuously. So you use this when you see continuous. And this changes that A0, 1 plus or minus R formula to this. Your rate now is up in the exponent. And if it's growth, use a positive. And for negative is decay. So whenever we see the word continuous in the question, you do this. It just changes the 1 plus or minus R to the t power to that right there. Now, also, it has its own special logarithm. Log in base E, that's the definition of ln, the natural logarithm. And that's what this button is right here. So they go together. So every time you either see continuous or if you see E, you do the ln and the formula with E. Same idea though, everything works the same. We got to divide by -3. Negative 99 divided by -3 is 33. This will work the same. We take the log of both sides to pop the x out, but instead of log, it's the ln. That pops that x out to the front with the times. Technically, we could have used the log, but here's why it's better to remember natural log with E. We said this ln is basically log in base E. So what this means is this. What do you raise E to get E, to get itself? First power. So whenever you take the ln of E, it always equals 1. 1 times x is just x, so that's gone, which makes this nice because now you got to type in is that and then round it to the correct place. ln 33. Rounding the nearest 10,000th, that's 4 decimals, 1, 2, 3, 4, 3.4965. And in the Delta Math calculator, there is an ln button. I'll pull that up in a minute here, maybe. So number 2, well, -9. That gives you 86.1. Again, you saw the E, so you think, hey, natural log, ln. So if I take the ln of both sides, that pops the R out. And then that, again, remember, ln of E means what do I raise E to get E? That's 1. It's always equal to 1. 1 times R is just R. So you don't even have to worry about the ln of E. It's gone. Which makes it nice. All I got to type in is ln of 86.1. 4.4555. We don't have to bump that up because the next number is a 0. And we'll just skip 4. It's basically the same here. -1. ln both sides. Oops. That pops that m out. ln of e is 1. So 1 times m is m. We don't care about the ln of e. We'll type ln 31 in. This time it's 0.4339, but then the next one's 8. So that would bump the 9 up, which will bump the 3 up. Now on 5, just a little reminder here. If we get a repeating decimal like that, we don't want to use that. We'll just leave it as 39 over 9. We'll just leave that as 39 over 9. We can type that in just as easily as all those 3's. So ln of both sides. And then that's gone. It's 1, so we don't care about it. ln of 39 over 3. You can use alpha y equals. We'll just use the division here since there's no other numbers or anything, so we won't mess it up. 1.4663. And then on 6, you divide by the 7.7. But you get that decimal. We don't want to have to write that whole thing down. So we'll just leave it as 66.4 over 7.7 because we can type that in. ln of both sides pops the whole thing. That's gone. But again, you still have to divide by that -7 that's left over. So here's probably the best way to type that in. I would just type just the top in, ln 66.4 over 7.7. I could close it and then divide by 7, but I'll just hit enter and then divide by -7. -0.3078. All right. That's basically the same as it was before. Just remember, when you see E, use ln. And ln is just a logarithm with a base E. So it works the same as what we've done, just with a different letter. And ln of E is 1. So basically, you don't use it anymore. It's just gone because 1 times r is r, or whatever the problem says. Now for the word problems, again, you look for the word continuous. And all that changes there is instead of the 1 plus or minus r, it's e to the rt. Works the same way though. Suppose you invest the 2,000, so that's our starting. We still got to change that to 0.02. And we're earning, so it's positive. And you just plug this in. 2,000. Second ln gives you the e, and now I can just type 0.02 times 8. 23.47 and 2 cents. Same tricks apply though. Colony of bacteria grows continuously. Continuous. Going to use this formula. Rate of 10% each hour. 200 to start. And once, twice, 0.10. Now just be careful. It's 10% each hour continuously. Find the number of bacteria after 1 day. So we got to use the 24 hours. Our rate's in hours, so our time's got to be an hour. Type it in. $22.04. We're talking about whole bacteria here, so we'll just round up. Now, those two, you knew the time, you knew the starting amount. You were going to find the ending amount. And then same idea as what we did with the regular logarithms. You invest 3,000 into an account that grows continuously at a rate of 2.4% each year. How many years until it doubles? So I don't know time. I do know, though, if I double 3,000, I get 6,000. That's 0.024. Divide by 3,000. Take the ln of both sides. That pops the decimal, or excuse me, the exponent out to the front. We just said a bunch of times ln of e is 1. 1 times anything is just that anything. So we don't even care about the ln of e anymore. And we'll just divide by that 0.024. Type it in, we got our answer. ln of 2, close it. We'll divide that by 0.024. You could enter, then divide by 0.024, doesn't matter. Says the nearest tenth, 28.88, 28.9. A radioactive isotope decays continuously. There's your keyword. Make sure you use this formula. I know I've just said that a bunch of times, just reminding you. If you have 10 kilograms to start with, how many days until you have 2 left? And this time, we're decaying. So it's negative 0.50. When you're losing, when you're decaying, the rate is negative. Well, we divide by 10, 2/10, 0.2. ln both sides. That pops that exponent out. ln of e is 1, so that's gone. And we'll divide by negative 0.50. ln of 0.2, so you can just hit enter. Then we'll divide by negative 0.50. 10.7 days.